A person starts a project with a clear image in mind: a table, a storage system, a small structure in the backyard. The idea is simple. The materials seem accessible. The steps feel obvious at first, but as the process unfolds, the build begins to depend on scattered instructions. A video shows one method. A forum suggests another. A diagram is missing key measurements. A materials list is incomplete. What began as a straightforward task slowly turns into a chain of external dependencies. In everyday life, most small builds rely on fragmented sources of information. People gather knowledge from multiple places: online tutorials, printed manuals, advice from others, and personal trial and error. Each source provides a piece of the process, but rarely the entire structure. The system works when all pieces align, when the measurements are correct, when the materials match, when the sequence is followed without gaps. Behind this process, there is an invisible chain. Content platforms host tutorials. Creators interpret designs. Suppliers provide materials based on assumed specifications. Tools are used based on general guidance, rather than exact requirements. Each part of the chain depends on consistency, but consistency is not guaranteed. When one part of that chain breaks, the result becomes visible. A missing dimension leads to misalignment. A misunderstood step affects structural stability. A substitution in materials changes the outcome. The build no longer matches the original intent. Time increases. Costs rise. Frustration builds quietly, often without a clear cause. To reduce this kind of dependency, people begin to look for more structured approaches. Instead of relying on scattered information, they turn to systems that organize the process from start to finish. These systems come in different forms. Some people use fully assembled solutions. These are ready-made products designed to solve a specific need. The structure is predefined. The user interacts with the final result rather than the process. This reduces complexity, but also limits flexibility. The internal structure remains hidden. Others use modular systems. These involve predesigned components that can be assembled in different ways. The structure is partially controlled. Instructions are usually clear, but still depend on interpretation. Modularity adds flexibility, but may still leave gaps in understanding how each part interacts. Another category involves custom builds guided by general plans. These are often shared online or in communities. They provide an overview, sometimes with diagrams or rough measurements. This approach offers freedom and adaptability. However, it often lacks precision. The builder must fill in missing details, which introduces variability. Within these categories, a more structured format has emerged. This format focuses on complete build systems defined through detailed, step-by-step guides. Instead of presenting isolated instructions, it organizes the entire process as a single, continuous structure. This format works by defining every stage of the build in advance. It begins with a clear materials list. Each item is specified with dimensions, quantities, and sometimes alternatives. This reduces guesswork before the process even begins. Next, the layout is established. The arrangement of components is described in a way that connects each part to the overall structure. Measurements are not just provided individually, but in relation to each other. This helps maintain alignment across the entire build. Assembly steps follow a fixed sequence. Each step builds on the previous one. There is less reliance on interpretation, because the order is already structured. This reduces the likelihood of errors caused by skipping or rearranging steps. In some cases, the format also includes wiring or power configurations, when relevant. These are described in a way that connects functionality to structure. Instead of treating these elements separately, they are integrated into the build process. What makes this format different is not just the level of detail, but the continuity. The entire build is treated as a single system rather than a collection of parts. This changes how the builder interacts with the process. Decisions are made within a defined framework, rather than across disconnected sources. This type of format can exist in different ways. Sometimes it is presented as a finished device, where the structure is already implemented. Other times, it exists as a build-from-plan system. In this case, the user constructs the system using common materials and tools, guided by the structured documentation. The focus remains on practicality. These builds are often designed for household scale use. They do not require specialized infrastructure. The goal is to create something repeatable, where the outcome can be achieved consistently by following the same structure. For some people, this approach becomes useful when projects need to be reliable, when materials are limited, when time cannot be wasted on trial and error. It is not a replacement for creativity or experimentation, but a way to reduce uncertainty in specific situations. It can also serve as an additional layer within a broader system. A person might still use general tutorials or modular components, but rely on structured guides for critical parts of a build. This shortens the chain between intention and result. Fewer external variables are involved. At its core, this format shifts the focus from searching for instructions to following a defined structure. It reduces the need to interpret incomplete information. It creates a more direct path from idea to outcome. For those exploring this approach, structured guides exist that document the full process in detail. They describe each stage from materials to final assembly, allowing the build to be replicated with greater consistency. One example of this type of format is often referenced in the video description, for those who want to examine how the system is organized step by step.